previous class, we discussed about the carbon and its compounds. We discussed about the importance of carbon and how carbon forms different compounds. The property of forming long chain, catenation, and tetravalency of carbon, etc. etc. Today we are going to discuss about the allotropes of carbon. What is allotropes? Allotropes are different forms of the same element in the same physical state. In the case of carbon, carbon has three different allotropes. All these allotropes are in solid state, contains only carbon. But it have totally different physical properties. For example, in previous time, we know only two allotropes, graphite and diamond. You may hear about graphite and diamond. These two allotropes are totally carbon. Diamond is made up of carbon only, and similarly graphite also contains only carbon. Both are in solid state, but shows totally different physical properties. In recent time, we find out another compound also, another allotropes of carbon known as fullerenes. We are going to discuss about all these three allotropes. First one, diamond. Diamonds are formed inside the earth under the conditions of high temperature and high pressure. The temperature is about 1500 degrees Celsius and pressure is about 70,000 atmosphere. We can't imagine this much of temperature and pressure. Now we are creating artificially this temperature and pressure. By applying this temperature and pressure, we can convert the carbon, which is black and soft, to diamond, which is hard and shiny. South Africa is the leading producer of natural diamonds. In India, we get diamond from Madhya Pradesh and Andhra Pradesh. Vajrangarur in Madhya Pradesh, in Andhra Pradesh, and Panna in Madhya Pradesh. In the case of diamond, it's a crystal form. It has a crystal form. Each carbon is linked to 4 other carbon atoms by covalent bond in a tetrahedral fashion. This results in a 3-dimensional arrangement. Just like a net, you can imagine a net. In net, each point is tied up into 4 sides. So it is very strong. Similarly, each carbon atom in diamond crystal is linked to 4 other carbon atoms. So it forms a rigid structure, rigid 3-dimensional structure, just like this. This is the cause of rigidity of diamond. These 3-dimensional network are bonded covalently. This covalent bond is very strong and gives a rigid structure to diamond. Diamond is the hardest natural substance known. The only other substance harder than diamond is silicon carbide. It is known as carborundum, but it is a synthetic one. It is not natural. Diamond is basically colorless, but the impurities gives its different colors. And also the density of diamond is very high. It is 3.51 gram per centimeter cube. The melting point of diamond in vacuum is also very high. It is 3500 degree Celsius. Because of the its strong covalent bond needs a high amount of heat energy to break this its three-dimensional network. All the four electrons are covalently bonded and there is no free electrons in diamond structure because it do not conduct electricity. But diamond is a good conductor of heat. Its thermal conductivity is 5 times larger than the conductivity of copper. It easily dissipates the heat energy raised by friction. So it is used as an abrasive. Abrasive means the material which is used to dissipate heat. You may see a copper wire behind the fridge to dissipate heat coming from the fridge. And also many electrical equipments, we can see the copper wired structure for dissipating heat. So diamond is normally we used as an abrasive. Because of these special properties, diamond has an important role in our daily usage. It is used in cutting and grinding of other hard materials. For cutting and grinding of hard materials, we used diamond for cutting glasses. It is also employed in instruments used for cutting glass and drilling of rocks. Diamond is used in jewelry. Beautiful ornaments are made with diamonds. The refractive index makes it very brilliant when it is properly cut and polished. Synthetic diamonds. Now we prepare diamond synthetically, artificially. In 1950s, we start to synthesize diamond artificially. We heat graphite up to 1500 degrees Celsius in the presence of a metal such as nickel and iron under the pressure of 50,000 to 65,000 atmosphere. We can change the graphite into diamond by using these conditions. This type of diamonds we normally used for cutting, grinding and making other tools. Graphite. Graphite is another allotrope of carbon. In contrast to diamonds, graphite is soft, black and slippery solid. It has a metallic luster. It is a very good conductor of electricity and heat. You remember that carbon and diamond both are made by using only carbon. From where these two allotropes shows totally different properties, we can go through them. Both graphite and diamonds contain only carbon atoms. But the structure of graphite and diamond is different. Graphite contains layers of carbon atoms. In each layer, a particular carbon atom is linked to 3 other carbon atoms in a trigonal planar arrangement with a bond angle of 120 degrees Celsius. Thus, 3 electrons of carbon are covalently bonded to the other 3 carbon atoms. The 4th electron, which does not participate in bonding, is free. These electrons of various carbon atoms are free to move along between the layers and hence are able to conduct electricity. And this layered structure helps graphite to slide its layer, because this each layer has a weak covalent bond. The property makes graphites a good solid lubricant. The density is less than diamond. It has a value of 2.2 gram per centimeter cube. The melting point of graphite is about 3700 degrees Celsius. Graphite can be converted into diamond by applying high temperature and pressure. It is used as a dry lubricant for moving machine parts which operate at high temperature and where the ordinary lubricants cannot be used. You may hear about the lubricants. We use lubricant oils in machine parts. If it is these machine parts working, the temperature rises, so the normal lubricants will not work at high temperature. At this time we use graphite. This used for making electrodes in dry cells and in electric arcs. You may see the battery. If you cut battery, you can see a black rod in the center of the battery. This is graphite. It is used for making pencil leads. Because this layered structure, we can easily write using this pencil. And may see the pencil will conduct electricity because graphite conduct electricity. It is used for making containers which are used for melting metals. We can store melting metals by using the containers made by graphite. Another allotrope is fullerenes. It is discovered in 1985 by Robert F. Curl, Harold W. Croto, and Richard E. Smelly, 3 scientists. They were awarded Nobel Prize in Chemistry in 1996 for this discovery. Fullerene have a closed structure like a football. A typical fullerene named Buckminster fullerene has 60 carbon atoms. This structure is just like this. We recently discovered this allotrope and the studies are going on. It is formed when vaporized carbon condenses in an atmosphere of an inert gas. Vaporized carbon condenses in an atmosphere of inert gas. This discovery of fullerene has opened up a new field in chemistry. Fullerene has various sizes are being synthesized and their properties and uses being studied. In addition to above allotropic form, carbon also exists in 3 microcrystalline or amorphous forms. You may study about the amorphous and crystalline solids. These are amorphous solids: charcoal, coke, and carbon black. Charcoal is formed when wood is heated strongly in the absence of air. You may get a black structure. Normally we used to iron after burning the wood. That is charcoal. In the absence of air, when we heat wood strongly, we get a black structure. This is known as charcoal. This is widely used for absorbing colored impurities and bad odors from water and other substances. That means we used this charcoal in water purification systems. Coke is an impure form of carbon. It is formed when coal is strongly heated in the absence of air. This is used as a reducing agent in metallurgy. We studied about this in our previous chapter for related to metals and non-metals. These are the important allotropes and other carbon compounds which contains only carbon. In our next class, we are going to study about the other carbon compounds. That means carbon making compounds with other elements.